Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to take a look at the difference quotient. Now the difference quotient, or the difference formula for a function, is similar to the formula for the average rate of change. And actually, let me rewrite that there. Difference quotient is the better way to think of this. We use this a lot in calculus to measure how much a function is changing at any instant. To simplify this, the first thing that you're going to do is figure out what f of x plus h is. Substitute x plus h in everywhere that you see x in the original function. Simplify as much as you can. The second thing you're going to do is subtract the original function from that. At that point, if you're working with polynomials, everything that you have left every term that you have left will have an h in it. The third step is to write that as a numerator over h, and then we try to simplify the remaining fraction, usually by dividing out a common h from each term. One thing that will show up a lot is we are going to be seeing x plus h squared often. X plus h squared is really the same as x plus h times itself, and when we multiply this by distributing, x times x is x squared, x times h is plus xh, h times x, that's another plus xh, and h times h, that's plus h squared. Those two terms in the middle are the same, so we can combine them to be x squared plus 2xh plus h squared. Anytime you're using x plus h squared, you can just replace it with that expression. All right, let's try the first one. Find the difference quotient for the function f of x equals 3x squared minus 7x minus 20. So again, the first thing I want you to do is find f of x plus h. So I'm going to write the function the way it was, and I'm putting a set of parentheses every place x was. Then I'm going to put x plus h into each set of parentheses that I have. Earlier, I just showed you that x plus h squared can be rewritten as x squared plus 2xh plus h squared. Then I've got to distribute the negative 7, so negative 7x minus 7h, bring down the minus 20. The last step, I just need to distribute the 3 through that first set of parentheses. 3x squared plus 6xh plus 3h squared minus 7x minus 7h minus 20. Okay. That's the first step. The second step is we want to subtract the original function from this, and then we're going to put that result over h. So the f of x plus h, 3x squared plus 6xh plus 3h squared minus 7x minus 7h minus 20 minus the original function, 3x squared minus 7x minus 20. We're going to distribute that minus sign through so we can combine like terms. The 3x squared is going to be treated as a negative 3x squared at that point. Minus negative 7x, this is the same as plus 7x, and for the same reason, that's like plus 20. Now when we go to combine like terms, 3x squared, negative 3x squared, add to be 0. 6xh, there's nothing for that to combine with, so I'm going to write that down. 3h squared, same issue. Negative 7x, positive 7x, those add to be 0, so I can ignore those. Moving down the line, I've got minus 7h, and then I've got negative 20 and positive 20, they add to be 0. So this is my numerator, and if I rewrite the difference quotient here, I'm going to have 6xh plus 3h squared minus 7h all over h. I can factor out a common factor of h in the numerator, h times 6x plus 3h minus 7 all over h. Divide out the common factor of h in the numerator and denominator. and we're left with 6x plus 3h minus 7. That is a function that lets us know the rate of change for that function for any particular value of x as h heads towards 0. So in calculus, we would treat this as 0, and whatever value of x that we had, the rate of change would be 6x minus 7. But in this class, since we're not taking that last step, the difference quotient is that function. I wanted to do one more of these, and this one seems a little easier, but it allows me to prove a point to you. We're going to find the difference quotient for f of x equals 9x minus 16. This is a linear function. Again, first, I'm going to find f of x plus h, which is 9, put a set of parentheses where x was, minus 16, and then put x plus h into those parentheses, distribute 9x plus 9h minus 16. Step 2, I need to subtract the original function from that. And so I can write that on the line right underneath this. Let me just change colors a little bit. I'm going to subtract 9x minus 16. That's negative 9x plus 16. And when we combine those together, all that's going to be left in the numerator is going to be 9h. Now again, you could have done this, 9x plus 9h minus 16 minus 9x minus 16. Distribute that minus sign through. 9x plus 9h minus 16 minus 9x plus 16. And then the 9x's add to be 0. The 16's add to be 0, leaving you with just the 9h. To finish this off, we put the result from step 2 over h. H divided by h is 1, and we're left with 9. So notice that that is the slope of the line associated with this function. So we know that slope measures rate of change. This shows that the difference quotient can be used to measure rate of change as well. And in general, if you have the function f of x equals mx plus b, the difference quotient for that function will always turn out to be the slope. All right, that's it for the difference quotient. In the last video for this section, we're going to take a look at composition of functions, which basically means that we're going to substitute one function into another function.